Hey everyone, this is the third video we have on replay, and this video we're going to talk to Mark Erikson again, and we're going to discuss the source code for replay.
Sure. I've been spending all my time working on Replay's client, and it's the DevTools repo in our organization. Replay consists of a few different pieces. One is the browser client. What you see here is the Replay client, and this is fully open source. The repos here, it's public, and like you can see all the pull requests that we've been working on. Like actually, here's the pull request that I opened up earlier this afternoon. It's literally open source, like it's Mozilla licensed mostly because the code base started at Mozilla. Anyone can look at it, anyone can inspect it, and we've actually had a few folks outside of the Replay company contribute PRs. Now, obviously, we don't expect lots of people to do that, but we welcome actual PRs to improve the code. There's also Gecko Dev, which is our fork of Firefox. And this is the one that actually has the Redux DevTools integration in there. So if I were to dig down in here, I could show you the pieces of the code where the Redux DevTools are loaded into the page and actually capturing data from the app as it's running. This client, like I said earlier, is fully open source. And if we look at it, it's actually basically a fairly, well, somewhat typical Next.js application. So you've got your typical pages structure, and you've got pages for, looking at the team pages and the library and recordings and all that. If we start to dig down into the rest of the source code, though, pretty much everything lives under this source folder. And our code base can really be split into two different chunks. 80% of our code base is really a full-blown copy-paste of the actual Firefox DevTools source code, really as it existed 2 years ago. The rest of our code is relatively new and shiny Redux and TypeScript that we've written over the last 2 years that adds all the replay specific features on top of that Firefox DevTools starting point. So like the CSS inspector and the DOM elements and all that kind of stuff, those are React and Redux code, but they date back to the Firefox DevTools being rewritten around like 2015, 2016. That means that area of the code base is really old and has some really strange patterns in there.
Yes, I've seen as well.
Oh yeah. Whereas like the newer replay feature specific stuff, it's certainly not perfect, but most of that's in TypeScript and a lot of it looks more modern. So picking a somewhat random section down here, filter bar, I don't know what's down here, filter bar, checkbox, filter settings, that's a function component, inspector components. Yeah, here's a really old file. This uses something called React DOM factories. The Firefox code base for a long time could not use Babel and they could not use JSX. And so they had to use this really, really old style of defining the HTML output. Let's see, we've got a class component, we've got a string ref, we've got a function called div, the output. Like this is straight out of 2015. Literally, this file probably hasn't been touched since then. On the other hand, if we were to look at the UI folder where a lot of the newer replay specific functionality lives.
So another thing about like 2015 is that was when React started getting a little bit of pickup, and it started really hitting off, I would say even 2017, 2018 timeframe. So this is before all of that. And this is around the time ES 2015, which is what we know as ES6, started to come into play.
Whereas picking an entirely random file, here's the request body component in our network monitor. This file is written in TypeScript. It's a function component. It's using the React Redux use selector hook. We have actual JSX syntax. So there's a lot of variation in the different files in this code base because they were written in very different times by very different people using different sets of tools and constraints.
I think that's actually pretty normal too in most code bases, especially when people come into the code base you're almost coming in from the future essentially, and you're seeing a completely different version of React than everybody else was using back when they first made these dev tools.
Yep. So when I joined, I'd actually been poking through the code base for a few weeks before I actually got started. So I actually had a pretty good idea what some of the code base structure was. And honestly, one of the first things that I saw was that the code base was using very old style Redux code. I've been talking for the last couple of years about modern Redux with Redux Toolkit and all these newer patterns that I want people to be using. And Replay was doing exactly none of those. One of the very first PRs that probably the very first PR that I filed was actually adding Redux Toolkit, modifying the Redux store setup to actually be able to talk to the Redux DevTools extension. And then I migrated one of our existing very small reducers from vanilla legacy handwritten Redux patterns like this over to be new, shiny TypeScript Redux Toolkit create slice. And really that was what I was doing for my first few weeks, was I was just going through the code base and trying to modernize a lot of the existing Redux code. We figured out that doing all of that would probably take just the Redux code, like 15 to 18,000 lines. It'd probably take me like 3 months. Maybe I should only do a little bit of that and then move on.
I was going to ask you how much value you were getting out of it.
So that's the thing. Like, just migrating a reducer from the older legacy style switch cases and object spreads doesn't necessarily improve the code by itself directly, but you do start to get like converting the code to TypeScript helps. Getting the action creators generated for free is less code that you have to write. You're able to use Immer for simpler immutable updates. Immer freezes the state so that catches accidental mutations, and actually we've caught a few of those. So there are benefits from starting to migrate this code to Redux Toolkit.
One of the other things I'd like to say is that when you do these updates, it also reduces the developer overhead for the code that is currently existing in there, because they have less they have to look at, and it also is documented now this way.
Yep.
And the other benefit of doing it this way is that now developers who are going to start working on the project new can just copy paste from what's existing in this new fashion, rather than hearing about a better way of doing it but not having any example to use to look at what they need to be doing.
Yep. So this was literally my first PR to replay here, converting a reducer, adding Redux Toolkit, and swapping out some of the source setup. The second biggest thing I did within that first week, so our code base used the Redux Thunk middleware, and we use it a lot, but we used a custom version of the Redux Thunk middleware. So typically with a Thunk, you would have my Thunk, some arg, and you do, return dispatch, get state, and there's your basic thunk structure there. The Thunk middleware allows you to pass in some extra value at the time the middleware is created. And typically what this is used for is like injecting some kind of like a service API into your Thunks.
Third-party libraries or anything like that.
Yeah, so like maybe you've got your API wrappers for make a posts query, make a to-dos query for the back end, and you want the Thunk to be a little more testable. So you want to inject those so the Thunk is always calling, await extra.fetch some posts or something. But maybe you could swap this out for a fake API in a test, and the Thunk code doesn't have to change. So normally, whatever you pass in as the extra value is the third argument to every Thunk function. Well, the problem is that Replay was using a custom Thunk middleware, so that instead of having 3 separate arguments right here, it was actually one object with, say, client, thread, front, whatever. So it's one object with all these fields in there. And that was a problem, because, for example, Redux Toolkit's create async Thunk expects that this is going to be a standard Thunk with multiple arguments and not a Thunk with one object that has different fields. And I counted, there were 185 Thunks in this code base. Now, not all of them relied on your extra values here, but a lot of them did.
It sounds like you could update this, either an ESLint rule or a code mod or something. You could just run it through and quickly.
Heavy use of Control-Shift-H to search and replace across many files. So I knew that fixing this was going to be a major blocker for us being able to really start standardizing on Redux Toolkit across the board. So within my first week, I dove in, and I was actually going to do this several weeks later, and Jason, our CEO, basically kind of nudged me and says, you should do this right now. So I kind of took the hint. I'm like, okay, Jason, I will do this right now. But I went in and I proceeded to migrate all 185 Thunks to be multiple parameters instead of one object parameter all the way across the code.
Now, who approved this PR? That's what I want to know. Who went through it and verified every single instance?
I don't know how much time they actually spent reading it. I don't think they read every line of code. But the point is, like, we had actual working code, and it was Redux code, but it was very legacy and quirky style Redux code. So I've spent a lot of my time so far just going through a lot of the code and trying to clean it up. The Redux DevTools integration work that I did involved pulling in the Redux DevTools component packages, which are public on npm, and figuring out, okay, how do I mess with this, and how do I instantiate those components? What data do they need? Oh, look, the Redux DevTools components create their own Redux store. I'm going to have to kind of like hijack this, and I need to get access to the Redux store that is being rendered by that component. And then I have to figure out, how do I shove the Redux actions data into that store?
Yeah, so to be clear, the dev tools use Redux, and then they're using Redux to analyze a Redux or multiple Redux stores in your application.
It's worse. So the replay application has a Redux store. The Redux DevTools UI has its own separate Redux store. And yes, we're using them in conjunction to show actions from your Redux app that you recorded. You can see my observations here. Like, the way I made this work was incredibly hacky, and the fact that it actually does work is amazing. I'm going to have to go back and revisit this in a couple weeks when I start working on the DevTools V1 approach and actually kind of productionizing this. But I mean, the fact that I was able to pull this together in less than a week was amazing.
I love this comment. This is a terrible idea. Come up with something better, and yet this works.
Yes. Oh, I do not write beautiful code. I write code that works and is generally not terribly pretty. Another thing of what I've been doing, we noticed we had, like, we recently tried to add an ESLint rule that would auto sort our imports, or at least yell at us when our imports were not correctly sorted. And the problem is, what we found was that if we started applying the auto fixes and sorting all the imports in certain files, the application could break.
Yeah, because they were dependent on each other, something like that. The imports weren't statically created.
Certain files were dependent. Like, file A really actually depends on file C having been loaded already somehow. And if you reorder the imports, now file A is getting loaded, but file C hasn't been, and stuff breaks.
I know this issue. Oh, man. So how did you fix it?
So we filed an issue saying we've got some cases where this is a problem, figure out what to do about it. And I did some research, and I figured out that, okay, some of this is probably due to circular imports, where file A imports from file B and file B imports from file A. Well, only one of those two modules can be initialized first. And at the time file A loads, file B has not created any of its variables yet, so they're all undefined. And depending on what code needs to run right away in this other file, stuff could break. So what you have to do is unwind those tangled dependencies so that there's no longer a circle going on.
By creating a third file that then they can import from.
Yeah, so a lot of times it's about taking like that common piece of code that they both need and moving it out to a third file so you can change where the arrows are pointing in the dependency graph, or delaying how certain things are being imported using like async import.
I was thinking this issue would have been because of singletons.
Yeah, we have a lot of those. We have some very critical singletons.
Critical singletons. It reminds me of Angular, when I used to have to load script tags in a certain order, or else the app wouldn't load correctly.
Yeah. So what I did, there is a we're using Next, and Next is built on Webpack. So I added a Webpack plugin called the Circular Dependency plugin. And what it does is, at build time, it walks over all the dependency data, inside of Webpack, where it's parsed all the files, and it can figure out when there are cycles going on. And by default, it actually just prints a few of them, errors, and kills the build. I really wanted to know, like, tell me all of them. And I may have, so I actually was able to configure the plugin so that it would print these out.
So there were cycles.
There were 174 cycles in this code base.
That's a lot. That's no wonder it broke. Oh my God.
So what I've been doing for the past week and a half is just attempting to unwind all the cycles in this code base. Yeah, look at all those PR. So I filed what should be the last one today. It doesn't fix all of them, but we've gone from 174 down to 19. And the last batch of 19, I think, are ones that are both not easily fixable and also not terribly critical at this point. And this was just a very careful process of look at one of these chains, look at the files, open up a file, look at the imports, get a sense of what is being imported between the different files, and try to figure out how can I unwind things. Like looking at this one that I did today. Okay, here's one. So there was a file called create.js, which imports two different singletons. We have one that represents wrappers around commands you can send to the back end, and actually technically a different wrapper around commands you can send to the back end. And so this file was using this thread front singleton in here, and it was exporting this prepare source payload. Well, prepare source payload was being imported into this client file, but this client file is the one that was actually like, one of these files was the one that was exporting this commands thing over here. And so what I had to do was I moved this prepare source payload function into the commands file so it didn't have to be imported. That let me eliminate these couple imports from this file. And then I also had to delay import these two pieces down here. So by moving a couple functions back and forth and delaying the imports, I was able to break the circular imports between these two files. There's no silver bullet here. It's just looking at files, tracing imports, figuring out what can I shuffle around to make this not loop on itself.
Yeah, so it's interesting that you had to make these async, because I would almost consider that these async imports, like I get why we're doing them. And so once we've done the async import, even if it gets called again, you get the same promise back. So you're not importing it twice. But it's because we had this code smell in the first place of these circular dependencies that you're just basically trying to make it work to improve what's there. If you had access to the full pass, then you could go essentially and rewrite it completely differently. But at this point, you're just trying to make it work in a way that it's not going to break.
Exactly. I am a pragmatist. Like, would I like to table flip the entire code base, start from scratch and do it the right way? Absolutely. Can we? No. We don't even have time to go rewrite all the code that's in the, like all the Redux code that's in the code base right now. We have features to build. We have bugs to fix. So, it's trying to find that balance between how can I make the code base better for the long term right now, but also like, okay, I can't spend weeks head down rewriting code that already works. I need to scope my efforts and also then move on to like building a new feature.
A lot of what you want to do is prevention and not cures. So you don't want to have to do what you're doing right now, but the only reason you're having to do it is because this is how the code base was initially. Over time, as you start adding new files and new code gets in, then it should be less likely that you'll run into these problems in the future because you've already set the standards initially that you wouldn't get into this in the first place. And like you said, a lot of this is also old code that has been modified or updated or added to, and it's not like that old code was fixed up before we even got here in the first place as well.
Yep. So another thing I've been doing as part of this circular import unwinding, I have actually migrated some more of the reducers to Redux Toolkit Create Slice. And that's because a lot of the plain object action creators were sitting in files with like a bunch of thunks and other code, and it was those files with the thunks that had a bunch of extra imports. So by converting this reducer to Create Slice, I now get all the action creators for free, so they don't have to be defined in the other file, and they're all correctly typed and the code is simpler. By doing some of this other cleanup work at the same time, the reducers are simpler, the files are being split a little more along, roles and responsibilities, and it unwinds some of the circular imports. So do I know for sure that fixing 160 of the circular imports is going to magically fix all our problems? No, but I think it's made things better, and I've certainly had a chance to go through and do some general code cleanup in the process. So I'm hopeful that it's fixed some of the side effectful import stuff. I don't think it's made it worse, at least. Although I will point out that I've broken production at least 5 times during this refactoring process, including twice yesterday. I actually tweeted like, I broke production twice today. How's your day going, folks?
Oh yeah, I did see that one.
I was not joking. They were small breakages, sort of small breakages. Like I actually broke the unicorn console thing because it wasn't dispatching the action.
Oh no. Yeah, I've done that before too. And you can't figure out like, you're clicking it, why is it not working?
It's the hazard of moving stuff around. And frankly, we have very few unit tests. We have some end-to-end tests, but honestly, I'm not even sure how much of the code base they cover. So a lot of times we are kind of flying blind with the changes. You open up the preview link, you click around the app for a couple minutes, like, well, it didn't explode. Okay, get a review, merge it, done.
And as the team grows and you get more people, it'll be easier to find time to do those kinds of things. Because one thing that's interesting about being on a small team, which I've been on before too, is that testing goes by the wayside because typically you're focused on the app and the infrastructure and just making it work. And as you start getting more people, you can start to spend your time focusing on how do you make the development experience better? How do you make sure that the app doesn't break so that you can have a long-term company that doesn't have any problems, you have a better SLA, and those are things that you can build on over time. But usually right at the beginning, it's very difficult to get that because you really are almost 100% focused on features. And if you're not, then it's hurting the profits of the company at that point.
Exactly. Yeah. I was working on some stuff related to refactoring the reducer that stores all those console messages we were seeing, all the, increment, state value, like literally stores the data for those message entries.
Something I do want to say is that if you do have a lot of entries that show up in the console, it will take time for each of them to load. And is this something that you worked on to make that more performant?
Well, no. So that's because it is having to evaluate those expressions in the back end. Like it's making a network request. A Firefox process in the cloud runs that code and asks, what is state.value in that scope at that point in time, and then it has to send that back to the client.
I see. So that's why you don't need to have replay running to see the recording, because the backend is providing all that value for your browser. And you don't have to now have a client that can read it. The backend is reading it and then just feeding you an application that renders the output.
So I was going to go in and start refactoring that giant, complicated legacy style Redux reducer to Redux Toolkit. And the problem was I knew like there's a very good chance I'm going to break something here and we have no tests for this code. I would like to have some kind of a test. And this actually got really complicated because we actually break, like our code base breaks a lot of the Redux guidelines that I've been trying to get people to follow for years, which is also why like I can't just table flip this code base and start over. One of the things this code base does, it uses class instances to represent a lot of the things like an object preview. And we put that data in the Redux store.
So that's not necessarily that bad. That itself is not bad, but
the code runs. You can see that the application works. But number one, those fields do not show up in the Redux dev tools because we can't serialize the class. Like you just can't, like you run it through JSON stringify, you don't really get anything.
Oh, because it's a class. So you're saying when you stringify class, unlike when you stringify an object, you're not going to get the full output, but an object, JSON knows how to translate that.
Yeah, and you also can't reconstruct the class instance just from JSON.parse.
Yeah, this is the same reason why you can't store React components into a database, because it creates classes of React behind the scenes, not objects of an instance of a React component.
Yep. And then the other issue was my first idea here was, I can just export one of the messages added actions from the Redux DevTools, paste that into a fixtures file, create a store and a test, dispatch the action, boom, I've got data, right? Well, not only can the Redux DevTools not serialize the class instances properly, the same thing happens when you like try and copy paste the action object. So the action has those class instances inside. I can't copy paste it into a file. So then I had to go down the rabbit hole. It's like, okay, the class instances are created after we've received a WebSocket message from our back end saying like, here's the raw data, and then it gets processed on our client. It creates class instances representing like, objects and DOM nodes and those things. And then it dispatches the action containing those. Like how far back in that sequence do I have to go to like insert some test data to where I can have a store that works enough that I can render the console panel in a test and actually have it show something? So what I had to do in this case, I opened up our app in Chrome. I inspected the WebSocket that our app uses to talk to the back end, exported all the WebSocket network traffic, wrote a script that extracted all the messages from the back end and saved the file. And if we look at the test that I wrote at that point in time, it's pretty bad. And the other thing was our code base is so complicated, I could not just create a Redux store by itself with the reducers. I had to run the entire real sequence that sets up the real Redux store for our app in the test.
Oh, because there's so many cross dependencies on.
There are so many cross dependencies during the startup sequence. It is ridiculous. So what I did was I was able to export those WebSocket messages into a file, and there was a spot where I could bypass the real socket and inject those into the processing sequence. And by feeding that data in here, it actually got processed through, dispatched the actions with the class instances. And by the time we got past this await, now the Redux store actually had real, legitimate message data inside so that this line of code ran without exploding.
There's a few things here. We've got testing library with the render function.
Standard React testing library with a wrapper that shows the Redux provider and all that stuff. Right out of the docs.
And the web console app is the console itself with the output there. And now that we've rendered it, we're using the find by text and find by placeholder text that come off of that render function. Instead of using a screen here, we're getting it straight off the render. And those are, again, testing library API functions. And we can use that to find DOM elements in the document.
And so all I wanted to do in this test was, I know that the data that I'm loading in has 24 message objects, I think. Render them, verify that the number of DOM nodes that I've rendered matches the number of data items in the store, preferably more than 0 of them. And then like do a couple things like verify that one of them has some known text in there. And then if I type into the filter text box, how many of them have the word circle in there, and verify that there's only 5. So like do the actual filtering step and verify it behaves as expected, just as a basic check to make sure I haven't obviously broken this.
So you're using the WebSocket you're like sending WebSocket messages somehow?
Captured WebSocket messages. Like we expose a lot of the app's guts onto window. And so there's a specific place where we can inject pretend socket messages.
Is that something that's already there that you're just working with? Okay.
Yeah. I was lucky that some of these building blocks like this were already in place.
Okay. So you're using existing building blocks for injecting WebSocket messages into the application, and from there, the Redux store that you loaded, which is the whole Redux store, is going to run and process these pieces and run the entire app. Now that that's running, you can then render the web console just by itself without everything else, pass it the store, and then you have access to the DOM elements and everything else now from the rendered output.
And now it's just a basic React testing library test, one component, like an entire component tree, whatever. It's just a test. Look at it, verify that the DOM is as expected, click the button, type the input, verify it changes. The end.
That's a lot of work to get to the point where you can finally do a normal test.
But it was worth it. And in fact, Brian Vaughn has gone in and significantly built on this. So Brian has done a bunch of work to expand on some of that. Like, for example, we're now actually capturing some of that test data from our end-to-end tests. So like where I was originally like manually copy pasting a WebSocket export from Chrome, he's gone in and having trouble finding some of the PRs here. Like we run our end-to-end tests and we actually export all the real data from there. And I think we save some of that as fixtures. And then Brian has been able to go in and build on that. So like he actually reworked that test. So he was working with data coming from like captured tests. So he's been working on kind of like building out and expanding some of our testing story. We still barely have any tests, but we're starting to build up some of this better testing infrastructure so that it's at least possible to write more and better tests if we were to actually sit down and do it.
Yeah, and that's what's really important here is making sure that you have the infrastructure available so anybody can just come in and write tests and make sure things aren't going to break. And in fact, now if you have this testing infrastructure, when a PR gets put up, then you can say, hey, you need to make sure you write some tests for this. And here's an example that we've already written. Go ahead and copy paste or use what you need. And this is the process of doing that.
Yep. So you can see that, like, actually, I haven't even looked at this one closely. Brian's gotten it down to the point where we have like a load fixture data function. And I guess you can say, like, what kind of fixture data do you want to load? I want to load some console messages. And I think he also added some utils for kind of injecting truly mock data. Like I just want to add a fake message entry with like a known text or something. I believe there's like some util functions that would do that as well.
That's also pretty impressive considering the code base that you guys are working in.
Yeah, so like in fact, if I look at what that test is like right now, and I haven't even looked at it in a few weeks. So let's see, we've got a util function that filters out some very annoying warnings. Create our test store. WebSocket messages that's still coming from there. Okay, he did do some filtering on that. Maybe it's a couple of the other test files that are using some of like this exported end-to-end test data. Like it's nothing like this code base is far from perfect, but it's a real app. It does work, and we're in this for the long haul. Anything we do to improve the code base now pays off down the road.
Yeah, it is a phenomenal application. And this is the thing that I'm most excited about is I would love to use this in my day-to-day and have replay work for me. Even back when I first tested it, it wasn't even available on Windows. So now I can use it on my own projects.
Funny you should mention that. So I think I may be the only person on our team who is a Windows user. Almost everybody else is Mac. So there have been times when I've run into something where certain tools or setup instructions assume that you're using a Mac. It's like, hey, I'm stress testing this. Let me actually just show a couple random bits of code just so you get a feel for what some bits of this look like. So I said earlier, we have like 185 thunks in this code base. And our code base is not a typical CRUD app. It does have a lot of very complex synchronous and asynchronous control flow. And those are really all done with thunks. In this case, like thunks are actually a pretty good use case because a lot of it is like we need to kick off a request, one of the client requests, the back end, which is actually going off over WebSocket. So it's not even an AJAX request. We have some work that needs to be done that depends on the store state. It's all synchronous. Like we don't even have to wait for anything. It's just check the state, grab this value, dispatch an action, and move on. Like this one right here is highly synchronous. This one's probably not even the best example, but this is a thunk that gets dispatched. Looks like it gets dispatched whenever we receive an event from our backend describing something about the way the data structures inside the recording have been processed. So the backend kind of breaks the recording into like short segments or regions, and it has to load them into memory off of S3. It's got to chew through them and figure out like where are the pause points, what events occurred, all those sorts of things. So the backend has to do some basic processing before any of that data can be shown in our UI. And so we have to like ask it, like, tell me when you're done doing some initial processing. And so we're setting up a subscription to the backend, says, let us know when these are available. And then once we get that data from over the WebSocket, then we feed it into Redux and we say, here it is, actually do something. In this case, and I really haven't even looked at this function before, we've got some data about like how deeply the backend has inspected this and what sections of time have been loaded. And we're going to do some things like, figuring out if the data that we've processed is actually longer than what we knew about already on the client, in which case we should update the client side to say, oh, we actually have this much time to deal with. Like maybe we've processed 15 seconds worth of data and we only knew that the recording was 5 seconds long. So the recording must be at least 15 seconds long at this point. And in this case, it's going to take the data we got from the back end and kind of like figure out like what loading progress are we at, and then dispatch an action that just says, here's the progress, so we can show it in a loading bar or something. This probably isn't the greatest example of some of the logic in this code base, but it is an example of a thunk that is looking at some of this data and processing it and dispatching some further actions. Let me look at one more.
I feel like we've hit a lot of points. I'm actually thinking of a spin already on the video, which is basically like, what it's like to work in a real application, replay, source code, something Mark Erikson, something like that, because I feel like that's what we've been discussing. And I've been trying to push that every time I'm responding to you, because I feel like that's a really good angle. And I think this is like a great take on the first time you come into a code base. I've been here for like 2 weeks. What does it feel like to be in something like this from a very high level perspective? And I don't mean high level like we're not talking about much. I mean high level like your high level, like your capabilities of what you can do from coming into code base like this and what you're seeing.
Yeah, and that's actually something I would like to talk about more myself some anyway. Like I've been intending to write a blog post for like 1.5 years now about like how do you dive into an unknown code base or something like that.
Yeah, you've already shown quite a few things on that. And I think that's like a really good angle for this particular video. Hopefully, I mean, I'm not sure, but there's way too much code here to go over it in like a single code conversation.
So looking at one more example of a thunk that actually does have a bit of async logic. So here's a thunk that manages updating some of the timeline display. So when this thunk gets called, we know we want to try to jump to a certain point of time, and we may or may not want to try to update the video display that matches that point in time.
The video display, essentially the DOM view.
Right. Yep. Or possibly the preview of that. So we're going to start by saying, okay, we have a Redux action that says like update our known point in time to here. And if we're going to actually try and update some graphics, now we actually have to ask the back end, possibly like, what did the screen look like at that point in time? So we have to ask the back end for that information. We get back some screen data and like a mouse coordinate so we can draw the mouse pointer on screen. But it's also possible that by the time we get the response back, the user may have moved their mouse and they're no longer hovering over the same point in the timeline.
So this is cancellation.
This is cancellation, yes. So if the hover time in the Redux state after we get the response back is different from what it was before we made the request, then yes, it's then cancel, bailout, don't update anything. Otherwise, the mouse must still be in the same place. So assuming we're actually trying to place stuff, potentially try and draw that graphics on screen.
Yeah, so what I'm seeing here with these, like the paint graphics is different. That's a side effect function, but the get playback and get hover time and all these other get functions are all selector functions.
Get current time and get playback would be selectors. Get graphics at time, I think, is a backend API call.
I thought it was a computed value. I might be wrong though.
I don't know. Let's look. This is
The last time I saw this must have been 3 years ago, so it looks different.
actually, I'm not even sure what. Oh, I see. We have a screenshot cache. That's why. And we may have to wait for the backend to provide us the screenshot. This is a pretty good example of how funcs can be used in the code base. So we've got some logic, might be sync, might be async, might involve talking to the backend, might involve a bit of processing. So in our code base, they go into thunks.
That was a great overview of the code that we had, and I really want to thank Mark Erikson for coming on and talking about the Redux source code and going through what it feels like to start into a project that's already got a bunch of code already and try to figure out where you can make an impact that's going to affect things going forward that can increase velocity and reduce the overload and make it so that even if you don't already have tests in your application, you can figure out a way to write some tests so that you don't break existing code when you go to refactor it.
Yeah, I spent my whole first month just doing code base cleanup and refactoring, like not even feature work. And it had a bunch of benefits. It improved the code base. It modernized a lot of the code with Redux Toolkit, like the part I was able to hook up the Redux dev tools to our app so we can use it in local development. But it also gave me a chance to explore the code base, see what the different sections are, start to understand what some of these concepts and terms inside the application mean, and get a sense of how things fit together. The code base is messy. There's no way around it. It's real world code. Like this is real code that has solved real problems and been around for many years. Do I wish it was better? Sure. But this is the code we do it. The good news is it's here and it works. And the application actually solves the problems that it's meant to do. We have a very good foundation to continue building new features on over time. And I'm really, really excited about some of the stuff we're going to get to work on over the rest of this year.
Yeah, me too. I can't wait to see it. I've been following your updates on Twitter, and you've got a bunch of cool things coming.
I'm having so much fun.
Hey everyone, if you liked what you saw, feel free to like and subscribe. I'd love to get any feedback you have in the comments section. If you'd also like to get in touch with me, I do read the YouTube comments, and I also am active on Twitter, and you can tweet me at Sautedos. Thank you very much. Goodbye.